So hopefully you graphed the other relation or function. And if you look here at this next transformed function, and again, this is the parent function, yikes, is y equals x squared, or f of x equals x squared. And when we transform it, we have our k as -2, which means it's a horizontal stretch by a factor of 2, which means we take all, if we want to look at point by point, when we transform this x value of -3, we would multiply it by -2. And then this is d is 1. This is a horizontal shift to the right. So then we would have -2 plus -2x plus 1. That would be -2 times -3 plus 1, which would give us 7. And with this transformation function, the y value stays the same. Oops. So you want to go through and do this for each value. So maybe pause the video and fill out the table. Pause. All right, welcome back. And you can see this point gets transformed to 5, 3, oops. This is 1, -1, -3, -5. And you can just blindly say there's no change in the y values. So I'm just going to recopy these values. So the x values got transformed. And the way to look at this is if you look at the original value 0, 0, where that got transformed to 1, 0, you can see here the min value, the vertex 0, 0, is now at 1, 0. And sort of another nice point is if you have -3, 9, so you can see here we have -3, 9 in the original function has been transformed to 7, 9, because there's also a reflection. So that's how each of the corresponding points. So what you might want to do, and I did this graph that you see here in Desmos graphing, try to do it by hand, compare it with this, and even remember in Desmos you can bring up the table of values to show yourself those. All right, so hopefully you've looked at this function before starting the video. If not, stop it and maybe go back. But if you look here and identify the different values and what they do to the original function, how they transform it, you can see your a is -2 and you've got this vertical stretch by a factor of 2 and reflect in the x-axis. And the effect on that on the original y value would be taking the original y value and multiplying it by -2. And then you've got your k value at -3, which is actually a horizontal compression by a factor of 1/3 and reflect in the y-axis, which would take the original x values and multiply each of the original x values by -1 over -3, or -1, or -1/3. Yes. And then here, the d is -3, since this is positive. So then we would shift left. So we would take that -2y, and we would shift it left 3 units. And when c is -1, we shift, I made that mistake. That would be the -1/3 x minus 3 units. We shift it to the left. And then finally, the c value is -1, so we take that stretched y value and we would subtract 1 from it. All right, so now fill out the other table of value, the corresponding table of value, meaning taking the original x value, dividing it by 3, and subtracting 3, and then the original y value multiplied by -2 and subtract 1. So pause the video and fill out the table and start it again. And also, actually, to keep in mind, when you want to transform, let's say you want to transform the -3 point, you've got the -1/3. We're basically dividing the original x value by -3, and then you're going to subtract 3. So we know that a negative and a negative is positive. So 3 divided by 3 would be +1, subtract 2. We get -2 here. And then we have the original y value multiplied by -2. And then we subtract 1. So that would give us -19. That's a 19. And then here, the -2 value, so let's say -1/3 times 2 minus 3. And that would give us -7/3, or if I just round it, -2.3. And then 4 times -2 is -8, minus 1 is our -9. So pause the video and fill in the rest of the values. Alright, so when you go to graph this, you graph the parent function first, which is this one. And when you go to graph the transform function, you can just plot the sort of the nice points. Yeah. And yeah, see if that helps. And when you do graph it, I would put the scale I used. I graphed it on some paper. I used the graph. I scaled it as 2 lines were 1 on the horizontal axis, on the x-axis, and on the y, I did each line was 2. So this would be 4, 8, etc. Just so you can fit the whole graph in. And since this was the vertex in the original, this is the vertex in the transform function. So, yeah. And you know then if, yeah, I'll leave that for you to graph. And like I said in the class notes today, if you do have questions, send me an email.